Hello. I was working on an interesting case. I have here an iPhone 15 Pro that had a bit of water damage inside. We can see the red marking there. It was sent by another repair shop, and they said they could see something weird on the battery connector. So the problem is that the phone excuse me, starts, but it displays 0% battery. Well, I started working on this one. Let me move under the microscope. And what I found is a lot of corrosion here near the battery connector. Otherwise the phone looks quite good. There aren't other corrosion marks all over it. But everything seemed to be here. Also, on this connector, on the old connector, it was missing this pin here. So the pin here has been completely corroded. Also, there was a lot of corrosion on the pads here that I've cleaned and I've UV masked. And I have replaced also the battery connector. So all the readings are fine now. Let's have a look together. Let me try to have the display here like that. Okay, and if we look on the schematic, right, we can see here the battery connector. So it looks like this. This pin was completely gone. This pin is going to this U4200 chip here, and the pin is analog bat V cell positive connection, and I think this is the negative connection, right? And we also have the plus line here, the ground, and here are the communication data with the battery, which is the clock line and the data line. Yeah, so if you watch the multimeter on the upper left corner, we can take some readings now here on the connector. Let me switch it to diode mode. Okay, so we are in diode mode, and yeah, this is the plus. We have 0.378. This is the clock line. It is a bit low compared to the schematic. This is the data line. This is closer to the schematic. Okay, this one should be OL, but I think we should have 2 point something here, because this multimeter can measure that. And this is the analog line, which is close to the reading. So the clock line is a bit low. Good. Now we can also compare with an existing known good board. I have one right here. Let's see what the readings are here. Yeah, so if I go to the clock line, yeah, I definitely have a good value. So the clock line is really nasty on the phone that we got. One more thing. I will show you now how this phone behaves actually. If I can ever get my mouse over here. So let's have a look on the behavior of the phone. This is quite interesting. Yeah, I'm gonna add a battery. Good. The first thing I noticed is that the power button does not work. Yeah, but I'm gonna connect the USB power supply. You're gonna see the readings up here, and if I connect it, look what happens. The phone boots. We're gonna wait for it to boot. Okay, the phone is on. I can't see the charging icon here, and if we look, it went down to 7 milliamps. So now I remove the power. The phone is still on. It says 0% for the battery. I add the power connector. It goes back to 6 milliamps. Remove it. Nothing. So still 0%. The buttons unfortunately do not work at all. I'm not sure if the problem with the buttons is something because of the water that was inside the phone. You know, before removing the board, there's one thing I didn't check, and that is what happens if we power on the phone using the power supply. I'm interested in the consumption of the board, although if the button doesn't work, we might not be able to start it. I think we can remove this battery from here. Yeah, and the power button should be on this connector here. So let's go back under the microscope. I'm gonna turn on the power supply, right? And we can see a consumption of 142 milliamps. That's not good. So it means we have somewhere something not working properly. Let me go, I think it's the 4th pin. No, none of the pins. That's interesting. Okay, so let's measure something else. Let's also measure the connector. I'm gonna turn off the supply. So we go back here to the this is where the button, the power button should be, and we should have like let's rotate this like this. It's the 4th pin here. This is the power button. Okay, and we should have like 820 reading. So let's see, 1, 2, 3, 4. Yeah, we're quite close. So it's not a problem. Let's see what voltage do we have. I'm gonna put the voltmeter in the multimeter in voltage mode. I'm gonna power on the supply. You can see there the PSU1, it's taking 140 milliamps, which is not very good. And we should have here something like 1 point something volts. Unfortunately, we have nothing here. So let me take the donor board and do a comparison. I have here a donor board. It's only the top board, but that's fine. There should be no real change. And with the top board here, yeah, you can see the connector. I'm gonna power on the supply, and let's see what voltage do we have here. So on the 4th pin we have like 1.5 volts, right? If we short this one with the ground, we should see the phone booting. Also notice there is no current consumption now. So this is a normal boot behavior, see? So this board is booting just fine. I'm gonna turn off the supply. And let's have another look here on the phone. So there are some nasty markings here near this connector. I'm not sure if that's liquid damage or what. That's really interesting. I've cleaned the connectors with some IPA, so maybe there are some markings from me cleaning down, but there was no visible Yeah, and these parts here are under some protection filling, so they should be fine, the diodes and those double filters that we see. And this part here should also be fine. I don't think there are problems over here, because this also had when I replaced the connector, I have indeed removed this protective thing, but it was there before. So I wonder if there was water there, if some water got in here, but obviously somewhere this board has water on it, and we don't know exactly if it's on the top or on the bottom. But first I would really want to have a look on the communication lines and see how they look. So we have multiple problems now. It's not communicating with the battery, and it's also not providing the correct voltages for the power button. Also on this, on the back, there was a lot of corrosion here too. That's not good. So all these pins are corroded. Let's try to clean them a bit. So there was water just staying on the back of this board. These are really bad. I don't think we can even use the let's see, I don't know if we can use the oscilloscope there, so let me do it like this so we have the same view. Good. So the battery communication pins are this one, which doesn't look really bad. It's weird that the grounds, so these two are grounds and they seem quite corroded, and this is the clock line, so this is the line that measures. Weird. And unfortunately we can see here, so look, corrosion went inside the board. See that? We can't even use this pad. So I see here some caps. I see some parts from on these holes, inside these holes, but I don't see any kind of corrosion on them. Neither on this area here. There is a big chip here. And some small parts in there, but there is no obvious corrosion. So the liquid stayed on this, in this area here. So good. Let's do the correct thing and just split the boards. I'm gonna get the heater. Okay. I'm gonna set this to like 240. Yeah, it's already there. It's 20 off, so it's gonna heat up to about 220. Yeah, I'm not gonna keep you here. I'm gonna pause the video and come back once the boards are split. Okay, so I have the board split. Let's move under the microscope and have a look on them. This is the top board on the bottom side. There is no obvious water damage here. Let's look on the bottom board. So I can't see any water damage on the bottom board either. It's only what we've seen here on the pads that are on the back of the board. Yeah, but here nothing really visible. Okay, let's measure again. I'm curious now what reading do we get on the battery connector. That should have been 520 on the clock line and 438 on the data line. Yeah, we are in diode mode now, and let's see, it's still low, so it's still 0.38, and that's not good. The other one, it's good. So we don't have a proper voltage here, and this one goes only to the PMU. Yeah, and that's bad. It means that we have a situation with the PMU. Let's see if we got the voltage back here. So here we should see something like 1.5 volts. Let me connect the power supply to the board. The power supply is on. No, it's not on. Now it's on. You can see it there. I still have 0.1 voltage. And this time we have something here like 0.8 volts. 0.8, but I don't believe the phone will boot up, will power on with this voltage here. See, nothing happens if I ground it. Yeah, so unfortunately that is a problem. But I don't understand those 140 milliamps, where they come from, and I wonder if there is any kind of water damage under this shield here. I doubt there is some water damage here. And I can't really see, so I see the holes, I see components there, but I don't really see any sign of water on those components or of corrosion. However, it can be further inside. But again, we have two separate situations. The clock line is not good, and the volume, the power button is also not good, and the power button again goes straight to the PMU. I really don't know where to go from here. Should I remove this shield? Maybe. Because that's where the water sat. I'm not really in the mood of replacing the PMIC, although it's a known issue. When the phone starts only when powered on, it's known that the PMIC is to blame. Let's look under the thermal camera. I'm still baffled about those 140 milliamps. But let me connect the power supply back. Yeah, so the power supply is connected, and let me get the thermal camera and see if there is something heating up. I suspect the PMIC. But I just have to make sure of that. Okay, let me start the thermal camera software. Okay, thermal cam is on. Let me power on. Yeah. So we can see the PMIC taking a hit right there. I can't see any other things hitting up. I'm curious here under that shield, but there's nothing. And on this side, yeah, we have nothing. We have the NAND there that is on top of the PMIC, and the board is glowing because of the PMIC on the other side. This is diffused heat. So I wonder if there is some sort of a short that could lit up that part of the PMIC. So we have one corner there only. That corner. Yeah, we have the 133 milliamps, and on that corner we see this corner here lighting up. It's a buck here. On the other side goes to the charging chip. Do we know what line is this? It's the 1V8S4. So 1V8, I think the 1V8S4 is used also for pulling up the I2C communication. Let me see if there's any resistor the 184 goes to. It's this one here. No, we don't care about that one. It goes here. That we don't care either. 1V8S2. It goes to 1V8S2 also. And this one goes here. The 1V8S2. And that's interesting. You know what? I'm gonna inject 1V8 into the 1V8S4 line and see what's getting hot then. And 1V8, let me start the supply. So you can see the supply, the second supply there. Let's do this. You can see there the PSU2. Let me grab a ground from the battery ground. And let's see the 1V8. Let's put this like that. The 1V8S2 is this one right here. Yeah, so we have 47 milliamps consumption. Good, let's let me bring you back to the thermal camera. Yeah, and let's see what's heating up. So 1V8S2, and we have the same corner of the PMIC heating up. It's not really bad, but it's there, see? Yeah. In the same corner. nothing else. Okay, so I'm afraid that we're gonna have to replace the PMIC. That's oh, that's not good. Okay. I'm gonna harvest a PMIC from a donor board. Then we're gonna remove this one together and replace it. I won't bother you with harvesting it because it's gonna be a lengthy process. Yeah, but let's see where it's going. I'm gonna pause the video now and resume once it's harvested. Okay, so I've harvested the PMIC from that donor board. I've reballed it. It looks quite good. Yeah, so this is what we're gonna use. It went really well. I'm gonna put this aside for now. And we need now to handle the worst part ever, and that's removing the old PMIC without damaging the board, the CPU, the NAND, which is just below it. And I haven't decided yet on what approach we should take. So for the starters, I'm just gonna gently try to remove the underfill. Now I'm sorry if you maybe will not see perfectly, but this is very delicate, so I will focus on performing this job rather than looking on the monitor display and see what you can actually see. This is not an easy job. Some skill is required. Yes, I'm gonna set the hot air to like 250 and 30 air. Yeah, and then I'm gonna hot air it. I'm gonna put some copper plate over the CPU, although this is not 250 is not that much. You see, everything here is underfilled, so if we use too much heat we will create bubbles. Also, part of the NAND is right below this chip, and I really don't want to flow the NAND, that's underfilled also. So I would prefer rather to break this chip and take it in chunks if we can manage, or maybe use the soldering iron to remove it. We can try that too, but first of all I need to remove this underfill, which is quite bad. It's not a nice one, and I need to remove it without moving any of these parts here, and without scratching the board too much. So you need to have a lot of patience during this process. I will probably speed up the video here. Alright, so the surroundings are clean now. So I decided to use this contraption here, this manual CNC crap. It's not very good because the board will never sit flat on this holder here. But let's see what we can do with it. It's gonna take me some time to set it up because I need to remove the how's it called? I need to remove the microscope so I can use the digital microscope, because we need to see what's going on there and I can't see with my bare eyes. So pause the video and resume when I'm back. Okay, so that's the best view I can get for us. Can't get any better. I don't even know when this is set. Okay, so the tool is on. Let me start it. Sorry, because it's shaking. Okay, so I'm gonna stop here. I have lifted the head. Turn this off and let me resume under the proper microscope. Okay, so let's see under the microscope what damage did we make. Well, it's not that bad. I don't think I damaged most of it. Interesting. So no parts were displaced on the sides. Now how do we remove that? The remaining. Let's try this holder. So it's really not bad. Whew. I'm quite happy with it. Okay. Let me try first to apply some Roman solder and see if we can remove with a solder iron something, and then we're gonna come with hot air. Yeah, so this is not gonna work like this. I'm gonna need a hot air. Clean this a bit. Okay, and let's try to actually scrape this off with a scraper. Gently. If there's a bit too much heat now. Oh boy, I'm breaking that pad. Okay, this is going well. Like this. Yeah. Remove the cap, no problem. Oh, Jesus Christ. That's not good. I slipped here. Okay, so this I'm gonna have to redo. Motherfucker, so this is really bad. I moved also the clock chip. Let's see if we can place this back. Okay, so clock is back. That cap there is not good. Okay, so my lunch is here. I'm gonna have lunch and then we're gonna do some damage control and see where we are with it. Okay, so I'm back. Let's do some damage control here and see what did we break and what can we fix. So I'm gonna add some flux and I'm gonna come with some low melt solder. I'm using 148. So I'm trying to replace the existing solder with some low melt so we can then wick it. Also, I'm curious to see, I had the impression that I managed to break a pad. I'm not very sure exactly. There's a capacitor there that flew away. So I lost some parts right here, but we're gonna fix this. Okay, let me come another time with some fresh solder. This again is 148. I think all pads look good. Keep rotating the board. Okay, so I have some component here. Oh no, it's just solder. Good, so let me switch to the bed tip that I'm using to wick. And let's get a piece of wick. let's try to make this. I don't know which pad was that I had a feeling that it's gonna break. And I really can't see any with issues now. Okay, I'm trying to make this low melt from the resistors and the capacitors. Good. So it looks reasonable. Let me try to clean it now with a Q-tip. Have a capacitor here that it threw away from there. Let me see, do we need that one? Let me rotate the board. And that capacitor is 1, 2, 3, 4, 5, the fifth one. 1, 2, 3, 4, 5. No, none of the caps on this line are needed. Good. Let's clean again. Okay, let's use some hot air, like 220 degrees, and I'm gonna carefully clean the sides. Okay, there is a pad that seems weird, this one here. Yeah, I think that's the one that I fucked up, but we're gonna fix that. Yes, I think it's pretty clean around here. Good. Let's have another look and see the pad that we broke, that I broke actually, not we. Let's switch like this. So the board is now like this. Okay, and I have a problem with the third pad here. Third pad here, this one is a ground, so I don't care about it. So the problem pad is a ground. Good. Then we don't care. Yeah, you can see it there. Perfect. All good. Let's clean the board. Let me come back to the top view. Camera is a bit off. Okay, and let's try to clean this the best we can. I'm gonna clean it first in this solution, which is quite dirty. Then I'm gonna replace this with fresh IPA. Okay, I'm gonna pause this for a second while I replace this. Good, back. Let's put some IPA here. Freshy, cleany. Good. Using this. Very good. I ran out of microfiber cloth. I have no idea. I had some left somewhere, but I can't find them. So I'm gonna use a piece of paper just to rinse this. Okay. Now let's have another look under the microscope. Let me put this back in the holder. Okay, so this looks not too bad. Yeah, you can't see it. So it looks very good. We need to fix those components that we're missing there. So let's look at this. Let me see. We need to rotate left because now it's this way here. Okay, so we have how many are we missing? We're missing one here on the right. Good. And that we do not need because it's on the main line, this one here. Good. And then we're missing 1, 2, 3, 4, 5. So 5 and the resistor here. Good. So let's see. 1 that we need. The resistor we also need. 2 we need. 3 we need. 4 we need. And 5 we need. So we need all these parts. Good. Let me see on the donor board. So on the donor board I have a few here. Let's clean this one and try to harvest whatever we can from this one. So this one I've kind of removed all the parts in that area because I wanted to remove the chip off here without doing any damage. So I'm gonna need all those parts that we have here. Good. So we are at 240. I need these two resistors. Let me try to remove this one. Okay. Good. Let's do some cleaning over here. Water is now on 220, so we're good. I think we're fine. Let's prepare our board. I'm gonna have to redo those pads, so all of them we need to redo. I'm gonna take some 183 solder on the tip of my scalpel. Okay, and let me spread some here like this. And like this, something like that. Let's see. I'm gonna take a different tip, straight one. So we're gonna have problems with the grounds because this doesn't have any kind of a heat inertia. So I'm gonna handle first that one. Good, that is good. Can you see something? Yeah, you can. This is good. 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 Let's see here. Good. 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 Dish. Okay, let me get some of this solder from there. I'm gonna add more flux. Good. This is a heavy ground. I think we're good. Perfect. So let's scavenge a few components. I hate these are different heights. Let me switch the board to a similar holder so that I don't need to change the focus when moving from a board to another. So let's set the focus here. Good. And let's start from this one. Where is it? Here. Good. So I'm gonna use 380 50R. That's a bit too much. I need to clean the tips of my tweezers. 1 second. Let me also clean the scalpel because it's full of solder paste. Good, so let's go again. Let's start with the first cap. Good. I think this will require the most heat. Good. Almost good. Yep. Let me give it some more flux. What's that dirt? Okay. Let's take the second one. Remember, they will solder faster because I'm using 183 to solder them back, and this is a high melt on this board. Good. Okay, let me add a tiny bit more flux. Here are some solder balls. Okay, let's go. Where is the third one? Good. Good. I'm gonna give them one more touch later if I'm not very happy with them. More flux. Okay, so we go for the outside resistor. Good. Don't lose it, don't lose it. Good. Tiny bit more flux. Let's grab the inside resistor. Good. Okay, that went on its place. Okay, and I'm missing one capacitor. Let me search for a donor board. Yeah, I have one here. Let me replace the donor board. Okay, so let's see, we are missing 1, 2, 3, 4, the fifth one. So it's 1, 2, 3, 4. Okay, the fifth one is the one after the resistor. Okay, let's I'm still on 380, which is not ideal. It's too much heat, so I'm coming on and off with the nozzle. Okay, I need to clean the other part here. Good. So I think now I can just lift this off. Okay, I made a mess, no problem. So let's go here. And let's sit the final one. Okay, perfect. So all are okay. Good. Now the board is a bit warm. I'm gonna add some flux because we're gonna solder the PMIC. But before soldering it, let me check actually if we have any short. So let's cool this off. cooling the board off a tiny bit. Okay, and now let's look again under the microscope and see if there are any shorts on the interposer side, on the side balls, because we could be misled. No, it's good. Perfect. Let's connect the power supply. Connecting the power supply now, and let's power it on. 1, 2, 3. The first one, PSU. Yeah, no shorts, so it looks good so far. And then we can proceed in installing the PMIC chip. Okay, so we have the board prepared here. I'm gonna put some copper plate over the CPU. Alright, and let's get our PMIC. PMIC is here, and it needs to be like this. Now I need to center this as best as I can, the best I can. I think it's good. I'm gonna use 350/40R. And I'm coming with a hit from above, from quite far away. And I'm gonna wait for it to drop. Did it drop already? Yeah, I did, because I can bump it. Weird. I had way too much, too little flux. Okay. I'm cooling the board off. Because of the lack of the flux, I hope there are no solder bridges under the PMIC, and I hope that everything is fine. I hope we didn't float anything. Okay, so this is the time that will tell us if we did something good or not. I'm gonna connect the supply. Now, first I'm just curious. Let's do a reading here on the clock line. If I can ever find my multimeter probes. So, clock. 0.5. Looks better. Good. Let's connect the supply. So power supply is connected. I haven't powered it on yet. I want to look on the power button connector. Where is it? It's here. Good, and I'm gonna power on the supply in 3, 2, 1. Excellent, so no sign of any short. Let's put the multimeter in voltage mode, and let's see what do we have on the power button. It's a bit difficult here. Okay, we have like 1.2. It's not that bad. I was hoping for more, but this could be okay. So now let's try to prompt the phone to boot in 3, 2, 1. Nothing. So the power button does absolutely nothing. That's not good. So let's see. Let's try it in the case. Let's do a bit of cleaning here. So I'm just gonna connect the how does this work? So it should be like this. Good. I also need this display. Is this on the display? Yeah. Let's connect the display. It's a bit difficult in this position. You saw that those 130 milliamps consumption are gone. Okay, so display is connected. Let me use something here so I don't short out this board, because we only have the top board here. And give me a battery. I'm gonna need a battery. Staying quite in an awkward position. I hope they make good contact there. Should I also connect this one? Okay. Cool, so let's see, we look on the USB supply. So it looks like before. Not really. At least before it was trying something. Now it's not doing anything. Switch to 5 volt. Okay, so something is not right. Let's get back to the drawing board. And I'm gonna reflow the PMIC. I really had no flux around it, so we're on 350. Let's heat it up a bit first. Okay, let me get some flux under it. And let's try to flow it again. Getting no movement yet. Yep. It is moving now. Maybe it sits better now. I don't know about this clock thing. That's what I'm gonna check next. I'm just cooling this off. And I'm curious what is going to happen. So you saw it was like dead, like not DFU or something. So I'm connecting the power supply. The power supply is on. Let's check again the voltage here. And this multimeter is far away. So we have like 1.5. It's a bit better. 1.5. Let's try a prompt to boot from here. Nothing. It's dead. It's dead. And I'm wondering why. Okay, let's turn off the supply. So we have voltage on the power button, but nothing there. Let me look closer. Do we see anything moved or bumped? Not really. The parts that we put back are fine, and here I can't see any issues. Okay, let me do something with that clock thingy. Let me remove it. Okay. Let me see if I can do anything with this tip. Something worked. I just used the wrong solder. Well, that's it, no problem. And let me take this one here. Imediat. Okay. And let's put it here. Some flux. Okay, good. I'm gonna leave it to cool off a bit and then try again. Okay, let's see again. What do we get? Let's connect the power supply. And power on the supply. We have 4 volts, no short. Let's try to prompt to boot here. Nothing, man. That's really weird. I wonder why. Okay, so this is the power button. And there are some caps on that side. You know what, let me try something here. Can we clean this without heat? Okay, so let me power on. I didn't see what I did, so I've removed that crap over there. Let me power on the supply, and let's short this one directly. Yeah, we have nothing there, and as in voltage, for voltage we have 1.3. 1.3. Why isn't it working? So we have the proper voltage here. I'm running out of ideas. I am running out of ideas. We worked just fine. Didn't mess with anything here. And there's one piece of gunk here. What's with this one? I hope there's no like disconnected coils or something. So this one I pressed, but it was cold, the board was cold, so I don't think there was any issue with it. I'm gonna remove the PMIC and maybe try with a different one. Let's give it 350. Okay, let me do some cleaning here. cools down. Let me have another look at the board. It looks reasonably well. Yeah, let's let me pull this off. Okay, now let's try to connect the power supply and see if we get any shorts. Good. Power on, no short. Probably my luck, it will never start. Hey! Yes. Yes. Well. Yes, no, maybe. Does it boot? Yes, it looks like it's booting. Oh my god. Good. Let me connect the display. No, actually, let's try to see if it charges. So remember, we only have the top board. Let's try to connect the top board. Let me first have a look here on the battery terminals. Make sure they are gonna make a proper connection. Good. Let me also try to connect the display without fucking up the board. Let me connect this one too. Well, at least the power button works now, so it's a progress. Now this battery is extremely difficult to connect in this position. Good. And now let's take the USB. You can see the meter there. Let's see what's going on. Good, it went to 8 volts, so it means it's gonna charge. See, it's negotiating. It didn't in the past. Well, come on, give me some image. Give me a screen. Yes, it is showing 12% battery. Yes. Do we have touch? Yes, we have touch. So, 12%. 13%, so it's coming up. Yes. So this is it. This was the problem. now I'm gonna have to solder it with the bottom board, and that's it for this repair. I hope you enjoyed it. It's already a bit long. I won't bother you with soldering back the bottom board, but yeah, this is a classical PMIC replacement for iPhone 15 Pro. Thank you for watching. Give me a like and subscribe if you like the video, and see you soon. Bye.